Today we're going to begin solving equations with square roots. The first type of problem you've seen this problem before. We have an equation, the square root of x plus 2 equals x. And the question is x equals 2 a solution? Well, recall that something is a solution if it makes the original equation true. So I work for A. I have my original equation, the square root of x plus 2. And it's important that you remember that implied is this is the positive root. It's not the negative root. That really does matter. Well, if we plug in 2 for x, either we get a true statement or we don't. Well, the 2 plus 2 is 4, and the positive square root of 4 is 2. So this is a true statement. I would say yes, it is a solution. B is a little different. We'll plug in negative 1 for x. So negative 1 plus 2 equals negative 1. Negative 1 plus 2 is positive 1. And the question is the positive square root of 1 negative 1? And the answer is no. The positive square root of 1 is positive 1. So this does not check out. The answer is no. X equals 1 is not a solution. So we've done things like that before. We're just testing, do we get true statements or not? If we get a true statement, it's a solution. If we get a false statement, it's not a solution. On to some equations. Now we're actually solving. Let's solve the square root of 2x minus 1 equals 7. Now one thing to notice, or a couple things to notice. The square root is by itself on one side of the equation. Everything without the square root is on the other side of the equation. That's an important feature when you're solving square roots. Now, to undo a square root, I need to square both sides. So the left side squared must equal the right side squared. Well, if you square a square root, you just get 2x minus 1. When you square 7, you get 49. Now it's just like any other equation you've solved. We just need to add 1 to both sides. So 2x equals 50. And divide both sides by 2, x equals 25. And this appears to be our solution. Now square roots, though, are the kinds of equations where you can't assume you're right. You must check. Because many times you'll get a solution that is actually not true, and you won't know it unless you check. So you have to check with square root equations. If we plug 25 in, 25 times 2 is 50. And we want to know, is the square root of 50 minus 1 equal to positive 7? Well, 50 minus 1 is 49. The positive square root of 49 is 7. This checks out. So once I've checked it, I know for a fact that x equals 25 is a solution. Again, you can't assume with square root equations that's going to work out well. Let's try a couple more. You go ahead and try the square root of 3x minus 5 equals 5. Hit pause and give it a shot. Well, hopefully you did. The square root was already isolated, so we can simply square both sides. The square root of 3x minus 5 squared is just 3x minus 5. 5 squared is 25. If we add 5 to both sides, 3x must equal 30. So x should equal 10, but we cannot assume that this is right. If we plug this in, we happen to get 30 minus 5. And 30 minus 5 is 25. The positive square root of 25 is 5. This one happens to check out as well. Here we have an answer. Now someone might be asking, what would happen if it was not actually a solution? You would not get a true statement when you went to simplified. That's what would happen. Hopefully this makes sense. We just need to square both sides, simplify, And the only thing that's really different is you must check every single time when you're dealing with square root equations.